Hello, web programming students. Welcome to week 11. We're going to talk about performance and validation. So the power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. This is what Chen Berners-Lee said at the outset of the World Wide Web. Tim Berners-Lee was the guy who practically invented the World Wide Web. And his vision of the web was that it'd be for all accessible. So what do we actually mean by accessibility? We mean that websites, tools, and tech are designed and developed so that people with disabilities can use them. So this encompasses auditory, cognitive, neurological, physical, speech, and visual disabilities that impact access to the web. You can think about it in four major categories. Visual, so these are things like blindness, low vision or color blindness. Auditory, so deafness or hard of hearing. Motor disabilities like inability to use a mouse, slow response time, limited fine motor control, and cognitive disabilities like learning disabilities, distractibility, inability to remember or focus on large amounts of information. These are the main ones that you should be aware of as you design your sites. Accessibility also benefits people without disabilities, like this curb cut, also known as a sidewalk ramp here. By contrast, this curb here is inaccessible. So it's also potentially dangerous for the wheelchair users. If you're coming off of it, it could be very dangerous to roll off of this curb. It's not a firm footing here. Or if you're trying to go from the street to the sidewalk, you have to jump the curb, and that could also be very dangerous. So our web design should be accessible and barrier-free, like sidewalks with curb cuts. Accessibility on the web also creates social inclusion for the aging and people in areas of low internet bandwidth, like in rural areas or developing countries. So how do we do it? How do we do accessibility on the web? There are a number of things. Screen reader software reads web content aloud to a blind person so that they can consume the internet independently on their own schedule as soon as the content is published. In the olden days, the blind would have to go to somewhere to have someone read them the newspaper or a book or something, or go to a library for an auto recording of the news. So now with screen readers, they can consume the internet, the web, just like anyone else would, with a little bit of modification. How else we can do accessibility? One thing is alt text for images. I've mentioned this before, but here's an example. So if I were to have this this picture here, we'd have the image tag, the source, of course, and then the alt tag here, this attribute here could be very descriptive. Photo of gray cat sleeping in front of blue wall is descriptive, and it describes what's going on in the picture for someone who can't actually see it. You can write descriptive links. So instead of saying click here and using that as your link for your A link, you can use nouns to be more descriptive about what it actually means. So what happens is the screen reader will read that this is a link, but without actually knowing what this sentence starts with, it'll pick up this link here and it'll just say here, and it won't have any other context for a blind person. So having it more descriptive, your links here, it helps a blind person understand what's actually happening when you click this link. We use HTML headings wisely. So we're talking about H1s, 2, 3, 4, 5, and 6 to make your content flow logically, because screen readers rely on the hierarchy of a big H1 heading and then a less big H2 heading and so on to convey information. So they rely on the hierarchy of 1 through 6 if you go that many headings to divide the information on a page. We want to use captions for images and transcripts for audio and video. So you may have a caption here describing what this picture is. Maybe you have the text that's in here or some other explanatory content. So let's talk about something called WCAG, or Web Content Accessibility Guidelines. These are international guidelines set by the World Wide Web Consortium. otherwise known as the W3C. And so we'll talk about what they like to look for in accessibility. They have an acronym, a really handy acronym for accessibility: perceivable, operable, understandable, and robust, or POUR. So perceivable means to the senses, that is vision and hearing, through a browser or assistive tech like screen readers or screen enlargers. So a screen reader, almost like the dictation feature in your Mac, it'll read a website to a blind person, describing it for them. Operable, so users can interact with all the controls and interactive elements, either using the mouse, a keyboard, or an assistive device. So if they can't use a mouse for some reason, they can use a keyboard. Or if they can't use a keyboard, they can use a mouse or something else entirely. So either way you do the interactive part with a mouse or a keyboard or something else, those options are available to people with disabilities. You want content that's understandable, that is to say it's clear, it limits confusion and ambiguity. So you want to be clear in your content. You always want to do that anyway. So you want to be really clear for someone who can't see what you're trying to put on the screen. And robust. A wide range of technologies, including old and new user agents and assistive technologies, can access the content. So even if a person is using an old smartphone or even an old computer that has internet access, they can still access the content. They're not limited by how old their tech is. You don't want to rely on color alone to convey meaning. To a colorblind person, meanings could get lost on the type of color blindness, depending on what they have. And sometimes screen readers won't pick up on the differences of color. So you don't want to exclude people just because they can't actually perceive the red or green or whatever color blindness situation they have. So when we're making different headings or trying to differentiate between different sections, use something in addition to color to make these separations. You can use a contrast checker so that your color combinations provide enough contrast for people with vision impairments. And this goes to more of the designy part of web design. You don't want to have maybe a light pink on top of a light gray. May not have enough contrast so people with low vision can't see it so well. So you want to have a high contrast between backgrounds and foregrounds. Let's talk about ARIA for a second. This is short for Accessible Rich Internet Applications. So these are HTML attributes that make web content and web apps more accessible. So HTML is great, of course, except it has a limited set of interface controls, so buttons and forms, that kind of thing. Developers got around this limitation by creating custom widgets in HTML and then using JavaScript to make the widgets interactive. So you can do things with them more so than you could with HTML. So you add a little JavaScript to the mix. However, the problem is that it's not accessible for screen readers and other assistive technology because there's no information embedded within the HTML or the JavaScript that explains to a screen reader what this widget was about. So it's kind of like styling a plain paragraph text to look like a big H1 heading. Even though it looks the same, it doesn't function the same. And that's where screen readers and their users get confused. So you want to avoid that. So HTML5, because it's very semantic, things like header or footer, that kind of word that actually means what it is descriptive enough on their own for screen readers. So a screen reader will see that tag and say, okay, this is a header, and then that's easily explainable for someone consuming it through a screen reader. But for tags like div, which isn't semantic, it only says it's the division. So we need a little extra help in the form of area attributes. So normally I would use a nav tag instead of a div here to make a navigation. But if for some reason you have to use a div here, you can add area to help a screen reader understand what this actually is, because a list of links or a list here may need to have a little more explanation. you may be, if you're cited, you could see it, but if you can't see it, then you need a little more explanation as to what it is. So we can add role navigation, this attribute here in the div tag. So to let a screen reader know that this div, this actual div, is for navigation. And that user will probably hear the screen reader say navigation landmark. So they use landmarks to tell people that are using screen readers, okay, this part of the website is a navigation. And so if they happen to scroll or move around the site, they can go back to different landmarks, including navigation, to actually navigate through the site, much like you would using landmarks to drive around, say, somewhere. Now I'll talk about responsiveness. So we can check our code for responsiveness. There are many ways to do it now, including built into our browser developer tools. So in the beginning, when responsive web design was coming out, browsers didn't have the capability to test this for you. And so a lot of websites came about that had testing capabilities. And I have a link to some in the module, but I will show you what this looks like in the browser. As far as cross-browser testing is concerned, the best way to see if your site looks good on all browsers is to check your site on as many browsers as you can find, on as many devices as you can find. So old phones, old laptops, old desktop computers, whatever you have, they may be good to hang on to just for the testing part, to see that you never know who and how someone's going to consume your website on. So it's good to test a bunch of different devices with different browsers. Short of that, you can use Browser Stack to check dozens of browsers and simulate different operating systems. And so you can really get a look as to what different browsers and different operating systems will show your website at. There are other options like Lambda Test and Comparium, but I've never tried them. They're also paid. Browser Stack's like free/paid. As far as page loading speed is concerned, obviously it's important for good UX because no one likes waiting for a page to load. I'm not. I always think, oh, this page is loading really slow. There must be something wrong with it. So you can use Browser Stack Speed Lab to test how fast your site loads. Google also has a speed tester. I will demonstrate both of them. Finally, we'll talk about validation. So what is valid code? Valid code is code that meets the W3C standards. Think of it as like perfect grammar, but instead of words, it's for code for the web. So why should we validate our code? Number one, it's a way to debug your code to find errors, maybe stray commas or brackets. A validator will find those and you can take them out of your code. Reason number two, it future-proofs your code. So code written to standards today will work with your browsers developed tomorrow. So if you have to use a lot of hacks, they may not work in the future. So you want to have your code as valid as possible so that you don't have to do a lot of backtracking and putting weird stuff in and taking weird stuff out. Reason number three, to validate. It's a great way to learn proper coding and to keep up with changing standards. So the W3C is very good about updating standards and implementing them into the validators. And so I pick up on new things when I go to validate code when I have to do it. Reason number four, it makes maintenance easier because valid code is easier for someone else to pick up and maintain if they haven't seen the code before. So you can find that hacks can be hard to untangle if you have to go in and figure out what someone did that wasn't to the normal standard. Reason number five is professionalism. You can show people that you are actually detail-oriented and show them the receipts. You can say, I'm a coder and my code is completely valid. Here is the proof. So we're going to do a little bit of this as your code demo for the week. How do you do validation of HTML? So there's a website. It's validator.w3.org, and I'll give you this in the module in the assignment, but you can enter your URL. You can either enter the website, or you could upload an HTML file, or you could copy and paste into the different tabs, and then it'll check how valid the code is. You can do the same with CSS. It's a very similar site. You can put a website in here or upload a file or copy and paste. And I'll give you that link as well. And so the result will return errors and warnings if there are any. So just for testing purposes, I put jefferson.edu through the HTML validator and it returned 12 errors and 7 warnings. So their code base has a little bit of a discrepancy between the full standard and how they used, but that's okay sometimes. Some errors are okay. Often they come from YouTube embeds. So if you want to take a video from YouTube and put it onto your site, their recommended embed code is usually the best practice to use. However, it's not technically valid according to W3C, which is okay. Sometimes vendor prefixes, if you have to use those, if you remember those from last week, they're classified as errors, but by definition, they're not part of the W3C spec yet. So this is also an acceptable error in your code. What we're going to do for our code demo this week is pick a website, any website, and we're going to run them through a few of these testing websites. So I'll demonstrate, and then I'll demonstrate on a few different ones, and then you'll do a similar thing with a website of your own choosing. So let's start with a website that I built a couple of years ago. I'll show you this website. So for class, I made this website. So this was a project showcase I made for demonstration for class, I think a couple of years ago or so. And I wrote out this code, and here is sort of a showcase of this art piece that I made for work. And so we'll run this through all the different testing websites. It's here at dynamite.github.io. So first, we're going to run it through something called the Wave Web Accessibility Evaluation Tool. So this will check it for a bunch of different accessibility things. So what you do is paste it here and click the arrow. And so it'll return a bunch of checks. So there's one error on my site. There's no alerts, that's good. They have 6 structural elements. There are no contrast errors, which is also good. So there's no problem with like backgrounds and foregrounds that blend together. There's 11 features. We can go through the details in a second. I didn't use any area attributes, so that might be something that might be necessary. But let's click the details. What it says here. So my one error is that language is missing or invalid. So what I didn't do was include an attribute in the HTML tag about the language that I've specified here. So I didn't say it was actually English in the beginning. So if I were to go back and fix this, I would add lang equals en in quotes to my HTML tag in the very beginning. And so next thing here, 11 features. So my 11, I have, I think 11 images here, and they show you, I have alt text. So a screen reader will read this alt text to a blind person using a screen reader. So I guess I had enough here. Could probably make it more descriptive, but they at least count them as good here. 6 structural elements. So I have one heading level 1. So this is an H1 here. Then I have H2s. Here, let's see, I have one header, which was this over here. Oh, this is my footer. Okay, so this is the footer here, and over here is the header. This is the header. Okay, so that's what these are. And this is a representation of the structure I have. So this was good according to them, and a header with an H1 and then H2s and then a footer. So they like that. There were no contrast errors detected here. I'll give you the link to the contrast checker, And then you can see if your color choices are high contrast enough. So I passed on the AA and AAA standards for WCAG. So that's good. I'll give you a link to what all the WCAG standards are so you can see for yourself. So this seemed to pass pretty well, the site that I built for demonstration in class a couple of years ago. So that's good. Now we can test it in the responsive web design tester. So let's paste the URL here. I'm using responsivedesignchecker.com. So let's see what this says. So I can pick a desktop or tablet or a phone. So I'll pick a desktop here. Let's say a 24-inch desktop. And so the site seems to look all right here. This is basically just a test to see how it would look at a certain screen size. So that seems to be okay. But let's see here. We got a tablet, we got Apple iPads, we got Amazon, we got different kinds of devices. So I haven't tested this on a Samsung Galaxy Tab 10. So let's see what this looks like. So, ooh, this image here is bursting through this div. So that's not good. I should probably fix that. Otherwise, any other problems here? Okay, so that's not bad. Got to fix this though. So let's see, we can try different things here. Let's see if I can do Apple iPad mini. Same situation. This image is a little funky here. No, it's good. Oh, it's all right. Okay. Also got a phone. So let's see. Let's try a Google Pixel. This is the Pixel 1. So not so great. This looks a mess. So I have to do something with these images to make them more responsive. Add more in heights and width probably. So you can see that even though it looks good on desktop, that's not really looking good for a phone. So something to work on for me. We can also check our responsiveness in the browser itself. So if you're using Chrome, you can go to more tools, developer tools, or you can do it by right-clicking or command-clicking, whichever it is, option-clicking. Inspect. And so if you select this icon up here, toggle device toolbar, I had turned it on. So once I turn it on here, you can pick different devices. So this one actually has more updated devices. So let's go for an old tech, so the iPhone 5. So this is how it looks on an iPhone 5. Still, that one image is kind of messy. So we got to fix that. We can change the orientation. So the orientation here, now on even on a landscape, it's a bit messy, so got to fix that. So this is how you can check your websites in the browser itself. Same situation in Safari if you really want to see it in Safari. So let's move down to website speed. So I actually ran this through the Browser Stack Speed Lab already. Gave me good scores for mobile and desktop. Page load speed was okay, looks like average. First contentful paint. So first contentful paint is the first thing that loads in your web page is sort of an indication to a user that, hey, this page is actually loading. And so this loaded in 1,000 or so milliseconds. So it took a second for something to show up. So that was an okay score for them. And speed index, 1.2 seconds. Okay. So on different devices, it shows you what it would look like. So a little slow on some older tech, iPhone 12, a little faster on Safari. Desktop on OS X seems to be pretty good. So here's an interesting statistic. Every 100 milliseconds of latency costs Amazon 1% in sales. So that's a lot of money for Amazon. And so you can see what else they have in the Speed Lab report. This is pretty cool stuff. Feel free to check this out on your own. Really cool. We can also check with page speed insights. So I'll give you this link also. Let's try my website on this. Click Analyze. So this gave a lower score. So this gave a more average score, 86. So first contentful paint. So the first thing that would load that would show someone that something's actually happening here with 0.8 seconds, which is a little faster than it was before. So that was okay. My page was pretty image heavy, so that could be why it loaded a little slowly. And so there's some opportunities here, serve images in next-gen formats. So they're talking about more advanced types of JPEGs, in this case, or more compression that load faster. And so here's other ways other suggestions for improving the speed of my website. So that's Google Page Speed Insights. Next, you can use Browser Stack Live to see what your website looks like on a whole lot of different devices. So you got Android, you got iOS, you got Windows, you got Macs. Just for example's sake, let's see what an iPhone 12 Pro Max looks like on, let's say, Chrome. So they give you this image of what that device looks like. So on my website here on Browser Stack on an iPhone 12 Pro Max, still got that weird exceeding the div size here, so I gotta fix that for sure. But this is how it looks, so that's good to know. And you got some options over here. So let's rotate the device, see what that looks like. Again, that page is really, this image is messed up here. And actually, probably could do better to make this a little smaller, do a few media queries to shrink this down a little bit, because that looks so great. You can change location and you can throttle network. I'm using the free version, so it times out after a minute, but start over if you want. So that's Browser Stack. So if you get into a lot of web design, you may want to get an account, a paid account for this if you really need to test websites, or if your employer pays for it, that's even better. So finally, we can talk about validation. So let's see if my code is actually valid. So I put it in here in the validate by URI. So I click the check button. And so I got a warning and an error. So here it says, consider adding a lang attribute to HTML. So that's just a warning. It's not an actual error. If you remember in the Wave evaluation tool, they called this not having a language an error. So from an accessibility standpoint, not having a language specified as an error. But from the validation point, they just call it a warning. So that's how you can double check versus accessibility versus validation. So that's a good way. They both flag this as a thing to fix. And then they have here an error on line 43, have an extra div tag, closing div tag. So that's something to clean up because I want to be completely clean. And then were I to fix these two things, then I'd have no warnings or errors to be green across the screen. So we can do the same for checking the CSS. So if I put a website in here and click check and green across my screen here, there were no errors in my CSS. So that's good. You can see here my valid CSS information. There wasn't too much of it. So not too much to get dinged on. So that's what the CSS validator looks like. So for your code demo for the week, what you'll be required to do is to pick a website, any website, and run them through, let's say, the Wave accessibility evaluation tool, and give me a screenshot of the website that you picked, and give me a screenshot of this. I want to see what website you picked and what kind of errors and alerts came back for it. So do that. You can use responsivedesignchecker.com to pick any of these devices here and show me a screenshot of what this particular website looked like. Maybe it's an Amazon Kindle Fire, but we'd like to see it. And then we use page speed insights. So pick a website, throw it in here, show me a screenshot of this score here so that I see what it looked like on mobile, and to also show you the new desktop. So desktop worked a lot better. So it's good to know. But show me a screenshot from your page speed insights check. And then you can skip the browser stack. You have to sign up for an account. So you don't need to do that. So let's just skip that one. Show me a screenshot from the validator. And so you'll see this in the module too. So give me a screenshot of this page and then give me a screenshot of this page. So you'll have 5 total: the Wave, the responsive design check, the page speed, the HTML validator, and the CSS validator. And that'll be your code demo. Because this week you're due for next week, your design comps, and then we'll get into some coding, and then there'll be a more meaty code demo for you. All right. Thanks, everybody.